So our next speaker is Jim Cantrell from Phantom Space, and they will be talking about achieving economic space launch.
So, yeah, thank you for having me here today, Bob Zubrin, old friend. Good to see you again. I like these discussions I hear on the Mars Society conferences like this. Sort of it brings me back to the early days in this business. You know, the far-reaching thinking and so on. I've been in this business 30 some odd years, and I guess I'm sort of at the more pragmatic end of it these days, trying to actually create things that are tangible and so on. There's room, you know, for both sides of this in the whole discussion. I'm listening to the last one on growing plants, you know, and thinking, you know, this is the stuff we'll see in 30 years from now. It's really cool to see it on the front end of it. So, what I'm going to talk about today is achieving low cost space access, and this is something I've dedicated probably the last 10 plus years of my life to, and was involved in SpaceX in the early days. As you probably also know about Bob and his early involvement as well. So at any rate, it's been something I've been working on for quite some time here. The need for low cost space access is not new. You may say, wow, this doesn't look like the shuttle. This is one of the very early designs of the shuttle. This started, you know, roughly about the time we were sending astronauts to the moon. NASA started thinking about how can we go into space more economically, and they're recognizing there's always a budgetary limit there. And what they came up with was the shuttle. You know, I would maintain that it was probably 20, 30 years too early. And with the technology we had in the 1970s, which is really what the shuttle was built on, you know, this is what we came up with. And of course, the Soviets had copies, and I've been over and actually put my hands on those years ago, but they didn't look a whole lot different than ours, I can tell you. The shuttle ended up being very expensive. It had a cost that was, by the time things were really flying, it was about 5 times what the typical expendable vehicles would cost. You know, you think about it, it makes total sense that, you know, you send 5 people up with a ComSat to place it in orbit. There's a lot of extra engineering, extra everything to go along with the people going up. So it's not really surprising that it ended up being so expensive. SLS, as it goes, by my calculations, is 10 to 15 times the typical expendable cost. So we're not learning anything there, at least at the NASA level, on reducing costs. So one of the things that you find when you start looking at vehicle costs, I know this is a chart and a lot of data and stuff, but basically the vertical axis is the cost per kilogram to send something to space, and the bottom is the launch capacity. And you know, nobody buys their ride on the cost per kilogram, but it gives us an interesting way to evaluate the relative efficiency of the vehicles. And what you start to see is, you know, there's a natural tendency for larger vehicles to simply be more efficient on a cost per kilogram basis. And so you've got a lot of the smaller vehicles that are coming along, Rocket Lab, Virgin Orbit, are fairly expensive in the cost per kilogram, but they're up there surprisingly with where the shuttle was. But then SpaceX, you know, building the bigger and bigger vehicles, getting the cost down, and there's a number of factors in SpaceX getting their cost down. One of them is just simply the size. And so you know, just keep in mind that one way to get the cost per kilogram down is to make a bigger vehicle. And if you want to launch a lot of small satellites, then you just pile them on sort of like a porcupine and throw them off into space. And that's really what's going on in the small sat arena is we're using the bigger vehicles with what we call Rideshare, and put a lot of these smaller satellites on board. So SpaceX is really the low cost leader, and, you know, they're Falcon Heavy, and then now Starship, you know, are just getting bigger and bigger. So that's driving the cost per kilogram down. Excuse me. But the real question is really where does that go? What's the real cost to put, say a small satellite into orbit? And a lot of what I deal with in the commercial side, I've given up the government programs about 20 years ago. And in the commercial side of things, we've seen more and more small satellites becoming the thing to do. And that's a growing part of the market. So there's an interesting, I think, competition growing between the large expendable or even reusable vehicles, let's just call it large reusable, and then the small mass manufactured vehicles. And really they're two simply different classes of things. It's like, taking the bus if you want to go somewhere versus driving your car. It's really a similar sort of comparison. So two economic systems in the launch that are developing. Reusability in all cases applies to both small and large, and it does reduce costs. There's a lot of non-recurring engineering in here. And if you go through the calculations, you find out that you only start to recoup your non-recurring engineering after about the 10th flight. So SpaceX is starting to do that. There was one booster they flew recently. I think it achieved 10 flights. But the main thing that it does for SpaceX, for example, is it gets the logistics down to a point where they can have faster turn on these vehicles. And if you have a large number of people working for you, and you can double the launch by just going to reusability, just not even factoring in the cost of the vehicle that you're saving, that doubling of your flight rate is a big way to save the money. So I argue that's a larger factor than the reusability itself. But we're starting to see SpaceX managing to get the reusability to the point where it's actually saving money on the per unit replacement value. So small satellites, in fact, I submit, are driving the future. If you go big, the main reason to go big is truly just to haul humans or larger things to the moon, that sort of thing. But the majority of the satellites that are going up are small, small being a couple hundred kilograms and lower. And a lot of this is constellation. So if you look at the future projections of the market, you're seeing just a huge number of these satellites, and it's driven by commercial money primarily coming into the industry. So all you have to do is watch how much money is being invested in the business to really give you a feel for the outcome of what the number of satellites are going to be on the other side. These kind of studies here come from Euroconsult data, which is, they go around and count all the satellites and so forth. But the other thing is to just watch how much money is going into the industry from private investment. It's still hitting records and growing. So I don't see this as a particularly overgrown estimate. A lot of people take issue with it, but I think it's very real. And I've seen we grew to 1,200 satellites launched last year, something like that. That's an enormous number, and that was a very real number. So let's back up to mass manufacturing. So this is Henry Ford, and I'm sure you all heard of him. And what a lot of people don't know or don't think about with Henry Ford is he really changed society. If you go back 100 years or more and you looked at the automotive industry, cars were a toy for the rich. They were something that cost, and then your dollars, $6,000, $7,000, $8,000, which is enormous. It's like buying a Ferrari or Lamborghini today. And there weren't a lot of people that knew how to drive them. And in fact, Mercedes forecasts the total demand ever in the world for cars was something like 3,000 a year because of the limit of the drivers. Henry Ford came along and said, well, I don't buy any of that. And if I make these on a production line, I think I can lower the cost so that my own people can afford it. And so not only he was a son of a bitch, by the way, by all accounts, but not only did he change the way cars were manufactured and lowered the price, but he also changed the way people had an expectation of being treated in the workplace. And so he was very revolutionary in a lot of ways, and changed our terrestrial transportation system forever. And people, of course, copied him as he went along on the mass manufacturing assembly line. And this is an example of one of his assembly lines back in the day. Probably this is like 1915, 1917, I would guess. And, you just roll the cars along, put them together rather than have one person, one car. This was one person, one station. So one guy would put just the tanks in, one guy put just the steering wheel in, and so forth. So this model took the cost down to about $400 or $500 a piece for some of the initial cars that came out of Ford's factory. So we've also done the same thing in missiles. So this is the Atlas missile. If you go back to the Cold War, when there was talk of missile gaps with the Soviets, there was talk of the Soviets are on our shores, they're in our backyards, they're everywhere. There was this sort of mania, and it's pretty amazing to see this assembly line sort of Atlas vehicles. These are vehicles that were being put together in parallel, but nonetheless a form of mass production in this. So that fueled the early nuclear race that we had with the Soviets. That of course had a branch off to the space race. But just to say that we've never mass manufactured launch vehicles is not true. I would argue that we haven't mass manufactured them efficiently. So, but these were things that were supposed to protect us from certain death and kept the peace, actually. So they did what they had to do back then. But interesting historically. So if you look at mass-produced vehicles and you compare what they can do on cost per kilogram, you get this effect called the learning curve. We see this in aircraft. We see this in everything that's manufactured. When you start your first unit, it's very expensive. Typically, companies won't sell at cost, right? They sell at expected cost down the road. So there's your first sales tend to be at a loss. That's why cars, for example, the Edsel is an example of a bad car that didn't sell. Ford put several $1 billion into that car and made very, very small sales. So they were losing a massive amount of money on every one of them. But had they managed to get up to say 1 million cars, they would have made money. So every car you guys drive, I assure you, the first unit cost to the factory, if they stopped right there, was about $100 million. And by the time you get to mass manufacture, you can buy these cars for $25,000, $50,000, $100,000. Same thing in rockets, and you can see some examples here. SpaceX costs, for the Falcon 9 are in the $1,500 to $2,000 a kilogram. So some of these smaller vehicles, and these are the ones we're designing at Phantom, are capable of getting down and being competitive with that, with total production units of say 400 or 500, which over a few years is not hard to get to, but you have to have the discipline and not change it every time. Everybody that's a engineer knows how that works, that they like to do that. So Rideshare also has hidden costs. So if you want to ride together on a SpaceX vehicle, you've got hidden costs of you have to actually engineer the satellite to the specifics of this and do a lot of extra testing. A lot of times you don't go to the right place, so you have to have propulsion, and then there's additional costs of launch delay because you don't get to choose your destination. So as it turns out, if you just compare it on a cost per kilogram with say dedicated launch, there's some additional costs that the satellite operators have to bear. So that's why, if you wonder why there's all these small vehicles coming about and getting funded, this is why. So there's a really compelling economic argument here. The big question is who's going to be able to actually build these en masse and launch them en masse, and those are two very difficult things to do, and that's where that race is in the small vehicles. There's an inherent attraction to dedicated launch on small. You can go where you want, when you want, and there's an inherent lack of delay. Some of these I've been involved in 11 startups in the last 15 years or so, and almost all of them, as we've gotten to the launch phase, have had to wait enormous amounts of time. It gets very expensive, when your burn rate's in the tens of millions of dollars a year. Waiting another year for a single satellite launch gets very expensive. So it's very compelling. There's a strong draw from the commercial community. Plus, uh, constellation replenishment. If you think about it, really only the small vehicles can do that. And there's more and more satellites going up in constellations every day. The market's really kind of evolved to, from a small satellite perspective to the SpaceX rideshare, and SpaceX has crushed pretty much everybody in this business. The Indians are still there, but SpaceX is really dominating a lot of it. Then there's a group of small launchers, and they're of various sizes, and I think they suffer a little bit from entering the market very early, and they made some decisions on the size of the vehicle and performance, and so they've got some limitations there. We at Phantom think we've got the solution that where we can eventually arrive at a daily launch kind of cadence and do it for fairly inexpensive. When I talk about our costs, we're doing a lot of supply chain where we buy our parts, like our engines and so on. So we know exactly what our costs are. And the thing will have to happen with us is working the learning curve to get the cost down as we go along. So, if you start to then look at the frequency of launch and the vertical versus the cost per kilogram, you can kind of see what I was talking about the large reusable vehicles being on the lower left-hand side. They're the inexpensive ones, but they're rideshare, right? And your costs then, tend to bump up the cost per kilogram. But that's something most people don't think about when they consider these things. And a dedicated daily launch kind of system, if we achieve it, will be really, I think, very, very attractive. However, it's got its limitations. It's small. It can't launch large things to the outer solar systems like we saw Lucy. Certainly couldn't launch the pods to the moon we just saw, and so forth. So there's a place for both of these things, is the way I see the market coming. And there's a lot of these companies like Relativity and ABL and Firefly who are seeing the inherent costs of the small vehicle at lower production rates, and instead of trying to solve the production rate and flight rate problem, they're simply making bigger vehicles. So we see this with Rocket Lab, who's going to make a bigger vehicle to compete with the Falcon 9 and so forth. So a lot of that competition is actually going to grow into that side of the market, is where we see it. So we're building something we call the Daytona. It's our first vehicle. It's about 450 kilograms to orbit. We believe we can sell this for $4 million and still make a pretty good profit. Our engine comes from Ursa Major up in Colorado. Our engines are qualified, so we're a ways down the road. We've been around quietly for about 2 years and haven't said much to anybody. We've raised a little over $40 million. We'll be, if everything goes as planned, we'll be doing our stage level testing this coming year, and then our first flight the early part of next year. And here's just some pictures of some progress, some hardware. You can see the engines coming out of Ursa Major at a production rate. They're learning as well as everybody else, how to move things into production. We've got our second stage in preparation for stage level testing and so forth. And we've been going through a lot of the qual testing on the engines and so forth. So a lot of progress. We don't talk about it much, but hopefully we'll show up on the launch pad and surprise everybody. So that's the end of my presentation. I'm happy to take questions or field tomatoes thrown at me or whatever.
Wonderful. Thank you so much. So as usual, we do have a couple of questions, and I encourage everybody to throw them into the Q&A panel, which is right next to the raise hand button. But we'll start with the questions that we have. And the first one comes from Adil, and they have two questions. Well, the first one is, when will we get to the single digits per pound in terms of the price per pound or kilogram in your estimate? And the second question is, are you also tracking the developments related to non-rocket related technologies?
Yeah, so first question, when will we get to single digit? And I assume you mean like $1 to $10 a kilogram. So I know a lot of people are speculating that Starship will do that. I'm taking a wait and see attitude. I do think that Starship is going to massively lower the cost. It obviously will, if you believe my data points, about how the bigger you get, the lower the costs are. And by that, that they'll get down around $100, $150 a kilogram. Whether they can reduce it further through reusability, will remain to be seen. I don't ever bet against Elon Musk. He's been the one thing in my life that's consistently surprised me at every turn. Every time I've bet against him, I've lost. So I'm not going to doubt that they'll get there. I think that's a ways away. And the other issue with Starship is it's so large. I think they're going to run into a flight rate problem just because we see it. What we're doing with these small vehicles. People worry about the seals and getting disturbed by the noise and things. It's a big issue. It's a bigger issue than you think. And the small vehicles, that's one of the reasons we think we can reach 100 is they have a very small footprint as far as the environmental disturbance. But we're starting to see that pushback at Boca Chica now. If he goes out to on a oil platform or something into the Gulf, then that might help. But there's still that intrinsic issue. So we'll see how disruptive that really is to launching satellites. It's definitely going to be disruptive to putting people into space and big stuff into space. So I think, like everything else, there's different parts of the market, and I think these things do coexist in the future. And then the second question was other forms of non-rocket transportation. Yeah, propulsion has not really evolved much in 50, 60 years. Maybe a little more efficient here and there, but by and large, it's still, massively lighting liquid oxygen, some fuel, and then blowing it out the back. And it's really primitive if you think about it. And there's a lot of technologies that people have come up with over the years. Electric, for example, is one of them, but there's not enough thrust there to get off the planet. So the real thing I would be looking for the future would be how do we get something that is a high thrust that can yet have a better performance off the surface of the Earth. And I'm not seeing a whole lot that's like going to be revolutionary yet, but maybe people are working on it and I don't know about it. But that's something if I had another 100 years to live, I'd probably be pursuing that.
Thank you. Next question is from Brian. How does Phantom's plan differ or align with Astra's plans for daily launch of small vehicles?
Yeah, we're very similar to Astra in a lot of ways. In fact, their new vehicles sized exactly the same as ours. We've got some key people that we've hired from there that we'll announce this week. So there's a lot of similarity between the two companies. But the reality is who's going to be able to create a daily launch. And as I look down the future, I think they'll be one of the ones that we actually compete with. I don't worry about relativity, for example. I know Tim Ellis, the CEO, personally, and I think their 3D printing technology is great, but probably wasted on rockets. And the rest of the guys are kind of chasing the Falcon 9, but I don't see Astra doing that. I think they're one of the true believers that in what I just talked about, which is daily launch. So I think we're going to be different only in how we implement it and how we manage it and go forward. So in any case, I think there's room for 2 or 3 of those kind of companies in the market, and so I don't worry about it. I just try to get up every day and do the best I can.
Thank you. Next question. We have seen a number of aircraft launched to orbit systems, and these seem to provide a niche in the available orbital launch options. So whatever happened to the raccoon concept? Is it just not engineering or economically practical?
Yeah, so if you've ever actually launched big stuff, big, even small rockets like we're talking about are big, and it's liquid, you have a real recognition of the practical difficulties you run into. And to put that on an airplane, more power to you. That's not something I particularly care to do. I've actually been involved with balloons, and same thing there. So I think some sort of air launch sort of thing can get you a marginal advantage that I think is eaten up completely by the disadvantage of having to put those systems remotely on a vehicle. They can be done clearly. We saw Pegasus for years. In fact, I flew a satellite off of Pegasus in the 90s. That was a solid rocket, and Virgin is a liquid rocket. And I understand from the people that work at Virgin, I have a number of them that work for me now. They would say every Monday morning started with, why are we putting the liquid rocket on the airplane? Shouldn't we put it on the ground? And by Tuesday morning, Richard Branson would come back and say, thou shalt put the rocket on the airplane, on the 747 with the Virgin logo. So there's a lot of reasons why you do these things, but I've never been a big fan of those. They're just technically complicated, and it's hard enough to do what we're trying to do without involving that extra step, in my view.
Thank you. Thank you so much for answering the questions and for the presentation. Oh, we actually have another one. It's from Dusty, and they say, do you know about JP Aerospace trying airship to space?
No, I'm not aware of that one.
Well, Dusty, if you could please maybe put the information in the comments or in the chat or in Q&A, that would be great. And again, Jim, thank you so much for the presentation and for the questions.
My pleasure.